this very popular math YouTube channel by Grant Sanderson makes the same exact logical error that Math Professor Steve Strogatz makes about music theory. So Grant Sanderson, he has the ratio 4/3 as music theory, and he's trying to present it as a Pythagorean ratio, and then he's trying to make an argument of why a better reason why the rational numbers with us smaller fractions sound more harmonious than the irrational numbers. And so then he says this is the perfect fourth as the ratio 4/3, and he plays the interval from the root tonic, and then he goes up perfect fourth, so it would be do, re, mi, fa, if you were using the pitch names. But as I've pointed out, the ratio 4/3 cannot be a overtone of the root tonic because the denominator is not a pitch multiple of the root tonic. So this is why in non-Western music theory, in the ragas of India, when you have two notes together and one is a perfect fourth higher and they sound together, then they explain that you will hear the perfect fourth that's supposedly higher. You actually hear that as the root tonic, as an octave below as the fundamental frequency. And so in Western math, what they call fundamental frequency, they use the 1-to-1 ratio. And so I explained that actually the perfect fourth has to be derived from the perfect fifth as non-commutative phase, as 2/3 in the opposite direction of the 1, and as C to F as a perfect fifth, and then it's doubled to be 4/3. And so somebody in the comments had also disagreed with Grant Sanderson, who argued that when the denominator is a lower rational number, then it's more harmonious based on probability theory. And so he said, well, if that was true, then 3/2 would be, as C to G, would be more harmonious than 2/3 or 3/2 as G to C would be more harmonious than 2/3 as C to G. So the problem here is when we're converting ratios of mathematics, instead of listening to numbers, and so we can't just reverse the ratios because we have to listen to the root tonic first, and so when we have an octave, then the root tonic is still the lower note, even because the perfect fifth is a natural overtone due to the two being at the same pitch as 1. So it's all based on what the 1 actually means. And so, of course, if you're using strings, then if the wavelength is 3/2, then the frequency is 2/3. But obviously, if you're just relying on the frequency of 1, then you can't have an undertone because the wavelength is longer than 1. It's 3/2. But in the Chinese tradition too, they're using pitch pipes. So therefore, the first note is 2/3 of the pitch pipe length. And then the second or the third note is 4/3 of the 2/3 pitch pipe. And so then you get 9/8 as your third note in the scale. But in the Western music tuning, you're changing the root tonic by using a double octave. And so the 2/3 is derived from using 6 as the octave as the root tonic. So then the 6/8 is your new 4/3. So instead of relying on reversing the direction of time from the 1, you are doubling the fractions of the numbers as a double octave. So the 2/3 is now 6/4. And then or the 3/2 is 6/4. And so then it can be reversed to 6/8 as the wavelength by doubling the 4 to 8. So as Professor Richard McKirahan pointed out, the octave has to be reversed. The lyre is flipped around so that the original octave was as the fundamental root pitch was 1/12, and then the new root tonic is 1/6 or 1/8. So now we have doubling the octaves, you're able to hide the fact that you're using the octave as the of 9, which is 3, and then times the